Okay, this morning we're going to work on Radioactive Decay Lab, which is lab 24 for you guys. So we have already discussed how to figure out radioactive decay in your notes. So your procedure, you need to put 100 small objects of a certain kind in there. Mine, I'm actually using M&Ms. The reason I'm using M&Ms is I need to know, after I shake it, is it going to be decayed or is it still going to be radioactive? So for me, because only one side has an M, if I see the M, I am going to say it's still radioactive. If I don't see the M, I'm going to say it's unradioactive. Okay, here we go. I'm going to shake. Lid on. 1, 2, 3. If I don't see the M, I'm taking it out. Then I'm going to say it's decayed. I'm going to keep doing this over and over until I have no M's left. So I'm going to share my data with you guys. So that's your procedure. 100 objects in, shake it 1, 2, 3. I don't care which way you shake it. It doesn't really matter because it's all going to be probability. Will it flip or will not flip? I'll put the data up for you momentarily. Okay, thank you. Okay, I've finished my shaking. So I'm going to fill in the data table. The numbers that are here show the number of decayed M&Ms. So I'm going back to my report sheet. Number before shaking, we started with 100 M&Ms. Number of objects decayed, the first time was 52. It's asking for percent decaying, so I need to flip them back. Number of objects removed, divided by number of objects before shaking, and times that by 100. So 52 divided by 100 times 100, 52%. I'm going to have you round to nearest whole number. Second, so if I had 52 taken out of 100, that meant 48 were left in the box. After the second shaking, 23 came out. So 23 divided by 48 times 100, 47.9. I'm going to round that to nearest whole number. So we're going to say 48%. If I had 48 originally, I take out 23. That means I had 25 M&Ms in the box for trial 3. Go back to trial 3. I took 15 out. So 15 divided by 25 times 100, 60%. Okay, so if I had 25 and then I took out 15, that means I had 10 left. I go back to trial 4 after shaking. 4 came out. 4 divided by 10 is 4/10. Times that by 100, 40%. So that means I had 6. Start with at trial 5. Shook the box. 4 became decayed. Four divided by 6 times 100. All right, I'm going to take 66.6 repeating and round to nearest whole number, 67%. That means I had trial 2, I only had 2 in the box. All right, trial 6, I had 2 in the box. Trial 6, 1 became decayed. So I'm at 50%. Trial 7, that means I started with 1, and after shaking, the 1 is decayed, so 100%. Now, you'll see your values here are random. It's all based on probability. If it was actual radioactive decay, each one would be 50%. That's how ours is different from radioactive decay. This is random, it's based on probability. Will it flip, will it not flip? How many times will it flip? It doesn't matter how you flipped it or how many times you flipped it, it's all probability. But in nature, this would always be 50%. So coming down here for your graph, what I did was I wanted to go by 5s, and I was short by 10. So I took a ruler, and I don't care for you guys, I know you probably don't have rulers at home. So what I did was I found out each one is about 5 centimeters. Nope, sorry, 5 millimeters or 0.5 centimeters. So I extended it so I can get it to 100. This one went by 5s, this I went every 3. So I am taking the number of objects before shaking, and I'm plotting it here to go with my trials. So trial number 1, it's at 100%. Putting my dot here. Trial 2, 48%. So I'm going to go a little below the 50, yes? So what I need you to do is, I need you to plot these. So go plot these, I'll be back, and we'll talk about how to figure out the half-life. All right, I went through and I finished plotting them. Connect it, remember it's a curved line, don't go with the ruler and try to get it all straight. So I had to figure out what is my half-life of this. I started with 100 objects. Half of 100 is 50. So I'm going to find the 50. I'm going to read over until I hit my line. And then I'm going to read down. If I read down, I'm just shy of the 2 trial. So with that one, I'm going to have to make an approximation. 0.3, 0.6, so approximately, I'm going to say around 0.9, 1.9 trials is my half-life. Whatever you start with, take half of what you start with, go to that value, read over until you hit the line, and then read down. If I started with 60 instead of 100, I'd go from 60 to where my 30 was, read over, read down. So half of whatever you start with. Find that, read over to your line, read down, tells you your half-life. Okay, make sure you're looking at these questions. The whole idea of the M&Ms is because one side had an M, the other one does not. So according to your graph, we just did this one. It's approximately 1.9 trials. Remember, I talked to you, the shaking has nothing to do with will it decay or not. It's all based on probability, so that's how it's different. That helps answer that question down here too. And it doesn't matter if I started with 200 M&Ms or 50 M&Ms or 60 M&Ms, percentage-wise, it's not going to affect my rate of decay. How many objects? Yes. The rate? No. All right, and no, you do not need to do a related problem, because I'm sure you don't have a cloud chamber, because neither do I. All right, remember, this is lab 24. Write it up. I'm going to need you to take a picture of this with your phone and share it with me. Good luck. If you have questions, make sure you email me.